Well, hello, friends. Today we're going to implement clock get time because I got a request from Dan for adding that, and I figured, why don't I just do that right away and record myself doing it? And then maybe I'll get a free video out of it. Let's see how that goes. So first thing we're going to do is just look up the Linux man page for it, because that's what I like to do. Okay, I don't want to buy whatever that is, but anyway, clock and time functions, blah blah blah. I've never used this API, so clock get time. So you get a clock ID, and then it gives you, I guess, a time spec, because this is a mutable pointer. And then these are the different clock IDs. So I know that he only wanted clock monotonic, I think. So I think basically the this is a Linux thing, right? No, it's a POSIX thing. All right. Then we should look that up instead. Clock get res. Okay, well, I want the newest version, please. Clock get res. Okay, finally. The resolution of any clock is get res. Get time should return the current value TP for the specified clock. Right, so the system has a bunch of different clocks, I guess, and monotonic is my understanding that the monotonic clock is a clock that's guaranteed to always increment. So even if you change the system date, then the monotonic clock will never like go down in value. It will always keep incrementing. So I could see how that's a very useful thing, because it's like this stupid classic programming problem where if you have some code that uses the like a get current time, it's very easy to screw things up if you don't take into account that the system time might change at some point. So anyway, let's implement this. So we're gonna do clock get time, and we'll put it in time.h. Okay. Set time we're not gonna do. Get res, I think maybe we don't need. So time.h. And he was also using NanoSleep, actually. Is that POSIX as well? Yes, it is. And NanoSleep is just choose a certain clock ID, you pass some flag, and then this is how much we want to sleep, I guess. And what is this, the remainder or something, if we get interrupted? Return value. What's RMTP here? Updated to contain the amount of time remaining in the interval. Right, so if you're interrupted by a signal, then there might be time left before it was scheduled to wake up, and then we'll put that in this time spec. Also, what the heck is a time spec? Time spec is, oh, it looks very much like a time val. Why is it different? Oh, it's nanoseconds. Okay, that's why it's different. So it's different from time val because it's nanoseconds. All right, so I think we have done enough research. Let's make it. So, what was it? Int clock get time. Clock ID was, okay, I already forgot what this thing was called. Clock ID T. Okay, and struct time spec. Struct time spec. And it was time t tv sec long tbn sec. All right. And let's, I don't know what a clock IDT is, so we'll just type def it to clock IDT. Will be an int, whatever. Oh, looky here. We already had time spec. So that's okay. I'm not sure why it says this is C++11 plus. Who cares? We are using C++11 plus always, so we don't need to gate anything on that, I think. All right. Then my nose is itchy. And then clock nano sleep clock id t flags struct, what is it, const struct time spec, oh, rqtp, sorry, struct time spec rmtp requested sleep remaining sleep. These names are crap. Like, people who make the C libraries, they, I really don't like this type of naming. Like, come on. I mean, I really don't like complaining about how other people choose to do their things, but when it comes to stuff that people make that a lot of others are going to use, I find this type of naming inconsiderate. Let's just leave it that way, or leave it as that. It's inconsiderate. Okay, so we're going to need these two functions. We'll put them in time.cpp. So what are they going to do? Clock get time. Clock ID. What did they call it? Clock ID. Yeah, I'm going to call it that too. I guess we can call it TS, whatever. And here we can assert, or let's see, do we have some value if we don't support that clock? E not sup. What about this other one? Clock ID argument does not specify a known clock. Right, so if clock ID is not clock monotonic, return in, oh no, not return, error no, is enval, return -1. I guess we can do that. And there's a flag here that they mentioned, the flag timer ABStime. If it's set, then we should be suspended from execution until either the time value of the clock has reached the desired goal or a signal is delivered. Right, or if it's terminated. Well, that seems kind of redundant. Like, why would I expect clearly I want the current thread to be suspended if the whole process is killed. Anyway. So I guess let's implement that flag also, because otherwise we... Wait, hold on. What the hell is the difference between this one and if it's set or not set? Cause the current thread to be suspended. Okay, I'm struggling to read this, so I don't know. We'll figure it out as we go. I don't know what it says. I can't make sense of it. I can't spell either. Timer, ABStime, 99. I don't know why. It just felt like it. Okay, so here we're gonna ask the kernel to dump out the current monotonic clock. So actually, I guess we could just, this should just all be in the kernel, now that I think about it. This doesn't belong in user space. So let's go in process.h. Where do we have sys get time of day? Let's put it next to him. Sys clock get time. And clock did t. I mean, we don't have to bother with these fancy types. Actually, we can just do it this way. But we do need this time spec. Okay, maybe we should bother with the fancy type. Okay, so, and then let's go in Unix types, which is the big fugly kernel header where we just add everything POSIX at some point here. So we'll do a struct time spec. Long TV exec. Def int clock id t. All right. Timer ABStime was what, 99? All right. Okay. We gotta restructure this. So we're just gonna do a straight syscall instead, like this. So clock get time, and we pass in the clock id and the ts. And for nanosleep, it's going to be similar, although here we have 4 things to pass, which means that it gets a little bit more complicated because we can at maximum pass 3 arguments to a syscall. So we have to put them in a little struct. We'll just make one like this. Flags, construct time spec, struct time spec, remaining sleep. All right. And we don't have clock id. Why not? Do I have to define that here too? Okay, this is getting annoying. Well, let's just put an int. Okay. And then we'll do the same with these, except since we need to pass the struct params. Clock, nanosleep params, X, requested sleep, remaining sleep. Okay, I think that is all we needed there, and then let's add the syscalls. Okay, now we gotta add them to the dispatch table, which is this big beautiful beast here. Haven't been adding syscalls for a while. Clock get time. Current process sys clock get time. Time spec arch2. Yeah, sleep. With this guy, we can just we just have to pass the big blob. Bum, 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 bum. And, oh, did I forget? Oh, I never added it. NanoSleep. Syscall, SC, const syscall. Okay, I think we are good. And let's add those functions in process. We can maximize this, make it a little bigger. Okay. So now we have moved into the kernel instead. Well, if clock id is not clock monotonic, eval. If validate, oh, this needs to be in process actually. If we cannot write to TS, then we return efault. It's a bad address. But if we can, then actually we can do this the other way around. So we can do switch clock id case clock monotonic. TS is, or let's see, auto now is could get time of day. So we don't have like we don't have nanosecond precision. We don't even have microsecond precision, actually. We have millisecond precision. So that's what we're going to get right now. I can't do any better at the moment, but we should probably do high precision timers at some point. But right now this will have to do. So TS tvsec is now tvsec. TS tvnsec is now .tv usec times 1000. It's just turning those micros into nanos. All right, and default return enval because I don't support that, and here we just say return 0. Okay, so I think that should cover clock get time. Now the sleep is a little trickier, so let's see how we would do that. First thing is we gotta parse the parameters, right? Because we got them in this big struct. So let's check if we can read them. If we can't, then we fault. Okay, and then clock id is params clock id, and flags is params flags. And then auto requested sleep is params requested sleep. Remaining sleep is params remaining sleep. Okay, if requested sleep, let's see, wait, hold on, let's validate these first. If params remaining sleep and cannot read from it, then we give you an efault. And if params, no, we wanted to write to that one, sorry. Requested sleep, we have to be able to read. Okay, now we have validated the inputs. So let's see, switch clock ID. Clock monotonic. Because I think we're going to piggyback on some existing sleep mechanism here for now. But what was this thing? In this case, excuse me, here we want to return e naught up if the clock ID argument is not a clock for which nanosleep is supported. Or, no, hold on, here. Or the clock ID argument does not specify a known clock. Yeah. So, we'll have to revisit these errors when we add more clock types. But right now, this is pretty simple. So what does YouSleep do? I think we could just be lazy here and piggyback on YouSleep. So let's just do that. So that would be the requested sleep tvsec times plus requested sleep TV nzac divided by Does that make sense? No. That makes sense. Okay, and then, oops, what does YouSleep do? More than that. It returns the ticks left. So the return value from YouSleep is going to be the number of ticks left, which we can divide by ticks per second to get the number of seconds left. Wait, so YouSleep returns the number of seconds? Return value. Supposed to return 0 on success. What if it gets interrupted? Just gives you enter. Okay, we may have a weird behavior here. Hold on, I want POSIX. Return value. Okay, so YouSleep should actually never return the remaining time. That's a sleep thing. Yeah. So sleep normally does that. YouSleep is not supposed to do that. So maybe we should just steal this because we want this. And then we should make YouSleep do the right thing. So Okay, YouSleep, I need to fix that separately, but let's not rely on it, so let's duplicate this functionality and do it ourselves down here instead. So let's figure out how many ticks we want to sleep. Or rather, how many milliseconds to sleep, because that's how we sleep now anyway. Or we can call it ticks, because a tick is a millisecond anyway now. So if ticks to sleep is 0, then return 0 right away. Ticks to sleep. And if if we wake up before, so uptime is the uptime counter. This is essentially the monotonic clock of the kernel. So it's incremented every time we get a timer interrupt or a tick. So this is effectively the clock monotonic of the Serenity kernel. I'm ignoring the flags thing right now. We'll get to that. Let's see. But here, what we want to do is, if we have time left on the clock because sleep returns early, then we just want to see if we have one of these. So, and we'll return e-enter in those cases. So return e-enter. Otherwise, return 0. If remaining sleep, then remaining sleep TV sec is ticks left until original wake up time divided by ticks per second. I guess ticks left until original wake up time minus remaining sleep TV sec times what? So we subtract this gunk here. Well, why is this type of shit so difficult? I hate this type of stuff. Basic arithmetic is not my favorite. Ticks left. Let's call it ticks left. It's a better name. And then here we can say ticks left minus remaining sleep TV sec. Okay. And now we just have to divide this by, or rather multiply it by 1,000,000, because that's how many nanoseconds were left. Okay. Good enough for me. I hope it's vaguely rightish. So what the heck was that timer ABStime thing? Can someone else tell me about this? If flags is timer ABStime, then it's interpreted as an absolute time as measured by the clock. Oh, so it's a time to sleep until? Rather than, like, so normally you're saying like sleep for 1 second, but if it's ABStime, then it's like sleep until the clock hits this exact value. So it's a little bit different, but ABStime. If remain is not null and the flags was not ABStime, then it returns the remaining unslept time. Okay. So if we have if we're doing the ABStime thing, timer ABStime. Let's just make this a little bit more. Okay, so it's absolute, let's say. So if remaining sleep, so if it's not absolute and we have a remaining sleep thingy, then we should. Is that what POSIX says as well? Is non-null. Okay, this is a little bit too opaque for me at the moment. The RMTP is only used in the relative sleep. Aha! Okay, so it's not used for absolute sleep. Okay, so good. Then we only care about remaining sleep in those cases. But we'll still give you e-inter if we're interrupted. Okay, so then here, ticks to sleep is going to be different if we're using ABStime. Let's see, so if we're using ABStime, then we need to, I guess we could just have a variant of sleep. It's like a sleep until. Okay, so if is absolute, then we do one thing. Otherwise, this is the relative path. Okay. So in this case, we'll have like time to wake. Wake up time is current sleep until time to wake. Okay, and then we're going to implement that sucker. And I realized that I could do this with arithmetic, but I'm not in the mood. And I like the expressive. Like, it's sad that there's a bit of duplication here, but I like that this is much more expressive. If we say wake up time like this, and yeah, I quite like that actually, because it's still very understandable. So sleep until. Okay, good. Sleep until is, where are you? Here. So time to wake, we can actually make a U64. This is a little bit weird. The timestamps are U64s and relative times are U32s. That's probably not right. Anyways, let's try to build and use this. So let's see. Well, what's wrong with that? Time spec. This is called time spec. Oh, wait, hold on. Where are we getting these things from anyway? Struct time spec. Okay, so that will probably build. Now, we should probably write some little code just to test this. So we'll just make a little program. Call it ds. get string as well. So int rc is clock get time monotonic, and we'll put it in our time spec. Okay, and then let's just print out what we got. I guess we'll just print it out that way. TS, tvsec, TS, tvnsec. All right. And then let's try nano sleep as well. So we'll sleep for a second using this clock nano sleep, clock monotonic. No flags, just do a relative sleep here. Let's start time spec. And we're going to sleep for 1 second. And you don't have to give me the remainder. It's okay. And then let's also do a relative. Or let's try that afterwards, actually. I know Dan wanted to make something fun with this API, so it seemed worthwhile to sit down and implement it. This is making me reflect though on like how much faster I can program if I'm not recording and talking at the same time. I'm not exactly sure how much faster it is. It's definitely a little bit faster, but how much is it? I don't know. So it seems very hard to measure such a thing. And now we are sleeping for a very long time. Crap. All right, let's see what's happening. Clock nano sleep. I mean, I know that I'm messing something up somehow. So it's not absolute, it's relative. So as the ticks to sleep is like a really, really huge number. So we were supposed to have milliseconds here, because ticks are milliseconds. Which means that we need to divide by 1,000,000, not by 1,000. Okay, numbers are difficult. There we go. That looked more like a second. Okay, and then let's implement a 1 second sleep using the absolute variant as well. So 1 second in the future, which would be the one that we got upstairs +1 and TSTV and sec. Like that. So 1 second in the future, ABStime. This should also sleep for 1 second. Well, that did not work the way I hoped. So, how did we screw it up this time? Let's find out. Wait, where was it? Get time. Nano sleep. If it's absolute, then time to wake is oh wait, hold on, this is a bit weird. I'm not doing this right because I'm fetching the what am I doing? I'm fetching the time of day here. That's not what I want to do. I want to just vend out the uptime counter. Like that. And then sleep until time to wake. Right. Sleeping from, well, let's do it this way actually. Q to Q. Or let's use LOD to LLU, sorry. From G uptime to time to wake. Let's see what it says. That seemed very good. Where did the logging go? Here. Yeah, that's really nice. Yep. Cool. All right. We are in business, I think. This is working pretty well. So let's go ahead and be brave and say that this is probably good enough. What were we doing? Just adding the types to time.h and the functions, adding the little syscall wrappers, adding it to Unix types so that the kernel can find them. This is such a hack. It's just a duplication header for like user space types, and we just slap them in a kernel header as well. Okay, then I added sleep until as a variant or an alternative to sleep. I think that's nice. And then we had to split the nanosleep syscall parameters into a struct so that we can pass them. Adding the syscalls. And here is the clock monotonic nanosleep. This could probably share code with other clocks, but since we only have one clock, I'm not going to bother generalizing the code right now. And same probably goes here. Or, well, this looks actually kind of same. But yeah, I think that's good. Kernel plus libc. Implement clock get time and clock nanosleep. Only the clock monotonic clock is supported at the moment, and it only has millisecond precision. We can, I don't have to. We can put one of those down, because that's nice. Okay, so I think I'm good here. So that's going to be it for today's video. This one was for Dan, because he wanted this API. Now you have it, Dan. Go and do your thing, whatever that was. We'll see if it leads somewhere. So I hope you saw something interesting here. And thank you for hanging out. We'll see you next time.